Hi guys, this is the last video of second week of online school and we are going to look into your homework that you did, and from there we're going to build more generalization of how to graph reciprocal functions and how to analyze reciprocal functions maybe without graphing it. Okay? Alright. So I already used Desmos to graph all my homework problems. So this one was the simplest one of them all. The function was just a 3 over x. So you might be wondering, what does that 3 do? And what does 1 over x look like? And I know in the first video that I didn't show you, or the bear didn't show you, the table for 1 over x. So let me show you the parent function. 1 over x, and what it looks like on a table. So we know that we cannot put 0 in for x, so we are going to choose 6 points to show you some important points. So I'm going to do these. So if you put -2, it will be just 1 over -2. And -1, but then once you start putting decimals in, it flips, right? So when you do 1 over -1 over 2, it's same thing as 1 divided by -1 over 2, which is same as -2. And then same thing for 1/2, it will be just 2, 1, and 1/2. So let me plot that on this graph so that you can see the difference between 3 over x and 1 over x. So what I'm graphing right now is a parent function. So it should go through here. Sorry if it's not very accurate. And then 1/2, it should go through here. 2, it should go through 1/2, and so forth. So you can see something did happen. It's not the same as what I'm graphing right now. So that 3 did affect my graph. How did it affect? Well, it multiplied all the y values by 3. So it's almost like stretching it, okay? So if you look at it here, it used to be 1, but now it's 3. So do you see how this point is 3, 1, 3, how it has been multiplied by 3? So this 3 affects all my y values to be multiplied by whatever that number that's on top, okay? But my asymptote is still x equals 0 and y equals 0. It's the x-axis and y-axis. Okay, so nothing happened to my asymptote. So then the domain would be from -infinity to 0 and 0 to infinity, and the range is actually exactly the same, okay? And my asymptotes are these two. So let's move on to the next graph. This one, it's a little more complicated than the first one because there is that 2, so it's stretching, but also there is now x minus 6. And you can already see from what I graphed here, you can tell that my vertical asymptote has changed to 6. So how did you get that number? Well, if I look at the equation itself, it looks like whatever made the denominator equal to 0 was my vertical asymptote, right? And horizontal asymptote still stays the same as y equals 0. Okay, so we have no evidence, no evidence to say that something affects y-intercepts anyway. That 2 has stretched everything, so it should have been right here at this point, but now it got multiplied by 2, so that's why now it's hitting -2 instead of -1. The same thing here. It should have been here, but then it's at 2 now. So if you remember the normal transformation, when it was next to x and you saw -6, it shifted left to right, right? So when x is affected, it's shifting left to right, but it was opposite from what you see. So since we see x minus 6, it's shifting right by 6. And it's still stretched by 2. So I just wanted you to see that the transformation rules still stay the same, whether it's a fraction or not fraction. So let's continue with our, so domain would be all real number except for 6, or you can write it this way. But the range is to 0, all real number except 0. Okay. All right. Now my vertical asymptote is x equals 0, so the same as a parent function, but now my horizontal asymptote has shifted. And do you see where the location of that place is? It's plus 3, but like outside. So the fraction is not affected. I mean, it's after the fraction, right? So it shifted up by 3. And when you shift up, you imagine all the asymptotes are going up together. So that's why my new asymptote is a y equal 3 instead of y equals 0. And it's very similar to the previous function. The only difference is that the previous function was x minus 6, and this one is 2 over x plus 3. Okay? So then domain is all real number except for 0. And range is all real number except for 3. Okay. Next. So now the number on top, we knew that it does stretch my function, but it's negative in it. So if you remember the transformation, the negative, what it did was it reflected over x-axis. So if you can remember the very first parent function, it looked like this, but now look at what your function looks like. It looks as if this got flipped over, right? So my new function is that yellow line there. Okay, so that's all that negative does. So it's been reflected over x-axis, it got stretched by 2, and it shifted right by 5, and that shifting comes from x minus 5. So shift right by 5, and that's why our vertical asymptote is getting affected, right? And the horizontal asymptote stays the same. So the domain would be all real number except x equals 5, and range would be all real number except y equals 0. So I told you to get familiar with interval notation, but also you can write it out as words like that. Okay, this one has everything, so let's look at this together. So 9 stretches my graph by 9, so every values from the parent function, it got multiplied by 9. X plus 3, well, that means that the x, so the graph shifted left by 3. So that means my vertical asymptote is x equal negative 3. And that 6 tells me that it shifted up by 6. So then my horizontal asymptote is now y equals 6. And so that's why my graph looks like this. And domain would be from negative infinity to infinity except for negative 3. And range would be everything except 6. Okay. This one. Now it's reflected too, right? So it was everything above and now reflected. So the first thing is the vertical shift. So it shifted left, because it's a plus here, by 4. So then my vertical asymptote is x equal negative 4. And it's shifted down by 2. Okay, so then that's why my horizontal asymptote is y equal negative 2. Okay. The 6 stretches all my values by 6, so you multiply 6 to your original parent function, and then you reflect it over x-axis. Okay, so that's why your branches are on the second quadrant and the fourth quadrant instead of the first and third. All right, I hope that was enough to get you kind of explore why certain asymptotes appear when, and how your graph is affected and reflected and all that. So to generalize, this is what's on your textbook, page 571, and this is how you can remember as well. So what if you want to analyze your graph without graphing? So the general form would be f of x or y equal a over x minus h plus k. So the reflection is part of this a. So if a is a positive number in this case, then your graph looks like this, right? So, but if a is negative, your graph looks like this. Okay, so that's all you need to know about a. And a stretches. A is a stretches the branches. So basically, multiply a to parent function y value. If you don't know what that means, you can just plug it in. Okay. Vertical asymptote is determined by the denominator. So you always set x minus h equals 0. And then h is basically x equal h. That's your vertical asymptote. Horizontal asymptote is simply y equal k. Okay, so whatever you see as a k is your horizontal asymptote, but whatever you see in the denominator, if you switch the sign, then it's a vertical asymptote. Okay, so let's look at this example because this is a little different. Because we haven't seen any number that is attached to x before, right? So the first thing I want you to do is actually factor out GCF from the bottom. Actually, it's not factoring out GCF. I want you to factor out by the number that is in front of x. So if it was 3, just factor out 3. And then you might end up having a fraction here, okay? So the reason I wanted to write it this way is because this is same thing as 3 over 2 times 1 over x minus 2. So what that means is that, do you remember the a that was on top? That's 3 over 2. So a is 3 over 2. So you need to multiply 3 over 2 to all your parent function y value to get the stretching, okay? What about vertical asymptote? Well, vertical asymptote is still whatever makes the denominator 0. So x equal 2. So this part could be just found by when you do 2x minus 4 equals 0. You still get x equal 2 as your vertical asymptote. So that wasn't the reason why I wanted to show you this process. The reason I wanted to show you the process is because so that you can find what a is. Okay. To analyze without graphing, this might be very helpful, but obviously if you have a graphing calculator can help you how to graph it. But because of the next section that's coming, I want you to be familiar with analyzing your functions without any graphs because that's what's going to happen in section 4. We will do section 4 and then we are going to do section 5 and 6 after a quiz, okay? So that there will be quiz over section 1 through section 4, so it won't be till next week, okay? So we're gonna probably cover 2 days for section 4, and then we will review for 1 day, and then we'll have an online quiz. So I think Sunday, Monday, Tuesday, Wednesday, we'll have an online quiz, okay? So please remember the homework, and if any of this was confusing, make sure you write me an email or comment so I can clarify certain things. And you have 5 questions for homework, and I want you to try solving these without graphing, okay? And I will see you next week. Bye.